Right. I guess I'd like to start just briefly with a little bit more about what I do and what I've done. I've worked at SGI for, I'll drive.
There's some slices.
Okay, good luck. Outlook isn't running.
Oh, then never mind.
Sorry. Let's see. So I worked at Silicon Graphics for 15 years. I started there in the first 100 or so people and did basically the same thing at NVIDIA. And I've been working on sort of geometry and curves and surfaces for the entire time. Recent years, I've been working with Microsoft, as Jonah was saying, on helping them and working with them sort of figure out the directions for the API and how to add geometry in particular in a useful way to the programming interface. So one of the things that we've been pursuing, in particular in the X11, was tessellation. And I'd like to, really it's important if any of you aren't understanding what I'm saying, you should ask questions, because I really want you to understand, okay? So let's start with, what is tessellation and what are the benefits of having it, okay? So tessellation is about the idea of taking a coarse representation, like you see here on the right, and creating a lot of geometry from that representation. So in fact, what was done to create this rendering is that coarse representation was diced into small triangles. What you see here in the rendering is just rendered geometry. There are no textures, there are no normal maps, anything. It's all geometry. Now, another aspect of that is displacement mapping. That was a smooth surface. It's not that interesting. But if you apply what amounts to a texture to that smooth surface and offset the surface geometrically, you can create incredible geometric detail. Again, there's no bump mapping going on here. This is all rendered geometry. Okay? Now, the benefit to that is that there's, from the perspective of manipulation and footprint in memory, it's a very compact representation. So you have bandwidth savings going across the bus from the CPU to the GPU. You also have pin bandwidth savings because all of the expansion is done on die. So this huge geometric complexity never sees DRAM. It all stays on die. Another aspect of this is that because it's a fairly compact representation, the coarse model, you can afford to do fairly complex animations because you're performing the animation on this sparse, compact representation. So it's much more efficient. Okay? Any question? Okay. Another facet of this that's also extremely important to understand is in games today, people normally, artists have to craft levels of detail for their characters as the scene varies. But because we're synthesizing the geometry on the fly here, you can actually, the programmer, the shader that's running on the GPU, can control how many triangles are generated based on the current camera view, based on the complexity of the character, based on a variety of characteristics. It also allows us to match the content to the platform. So if you're sitting there running on a four-way SLI system, you can afford to crank up the geometry to huge levels. But if you take that same content and then move it to a handheld device, you're not going to be able to drive the same geometry, but you can use the same content because you can control what gets synthesized. There's also this benefit that going out into the future as platforms improve, as a developer you can take the same content and basically just turn up the dials to get an even higher fidelity piece of imagery. So, any questions about this? Okay, great. So just a quick description of what's going on with displacement mapping. I'm sure some of you at least are familiar with this, but the basic idea is you can take a very simple piece of geometry, dice it into a very large number of triangles. This is actually also has a texture map applied to it. And then apply a displacement map. This is a very simple displacement map. It's grayscale, and the intensity of the image reflects how much you offset the surface vertically. And you can see what you get here is, basically this surface with the embossed letters A, B, C. And this is not bump mapped or parallax mapped, it's all geometry. So if you were to tilt this down and look at it sort of edge on, you would see the letters rising out of the page. You don't get the smooth silhouette phenomenon that we see in games today. So it's just another example that's a little bit more interesting, and this is actually some content that you will see in a demo later on today. We have a much richer displacement map that reflects a mountain range, mesas, ravines, rivers, and this is the wireframe that results from that in a particular view, and this is the rendered result with additional shading applied, obviously, because the displacement map doesn't give you colors. But obviously, you can take what is actually a single quad and produce thousands and thousands of triangles. Now, in practice, the amount of amplification that you can get from one primitive via the API is about 8,000 to 1, if my memory is right. Okay. So in fact, to get this level of detail, you have to actually break the ground plane into some number of surfaces, but still, you get huge amplification. So some other examples, I would assume that some of you at least have seen these. These are from Unigine. But looking at the model on the left, this is a simple, bump map shaded textured model. But if you apply the displacement mapping, you get a much, sort of richer looking character. But there's more than just actually the character. There's also the effects of the geometry itself. Looking at this house, you see this kind of classic, fairly old style kind of texture mapped roof. It's not even bump mapped in this case. It looks really flat. But also, you see all of these massive blocks and around the windows and on the corner of the building. They're casting really painted shadows. But if you apply the displacement map, algorithmically, you can cast correct shadows because the geometry is there. So you see these shadows coming off of the side of the building, off of the windowsill, and also obviously the roof is a much richer, much more representative rendering there. So